In this lesson, you will learn how to solve triangles using trigonometric ratios. In order to find missing sides, you will use the sine, cosine, and tangent ratios. In order to find missing angles, you will use the inverse sine, cosine, and tangent ratios. A sentence to help you remember the trig ratios is some old hippie caught another hippie tripping on algebra. So for the some old hippie, that helps you remember sine is opposite over hypotenuse. Caught another hippie helps you remember cosine is adjacent over hypotenuse. And finally, tripping on algebra is tangent, which is opposite over adjacent. Use this sentence to help you remember the trig ratios. We're going to find the missing side length and round to the nearest tenth for example number 1. We're going to use triangle STU to find the length of side SU. Because SU is our missing side, we'll use our variable x in order to solve. Let's start by labeling our triangle. We have our theta angle, 54 degrees. From that angle, we will label the sides of the triangle. So opposite the 90-degree angle is our hypotenuse. Opposite the theta angle, label your opposite side. And adjacent to the theta angle, label the adjacent side. Notice the side SU, the hypotenuse, we do not know any information about it, and we do not need to know any information about it. So it's actually best that you not label that side. Only label the sides of the triangle that you know or need to know information about. This will help you determine which trig ratio to use. Some old hippie for sine, caught another hippie for cosine, tripping on algebra for tangent. So notice in our triangle we have opposite and adjacent. This helps us to determine that we will use the tangent ratio. So tangent of theta, so that's 54, equals opposite, which is 87, over adjacent. So it's very important at this moment that first you've picked the correct trig ratio, and secondly that you've set it up in order to solve. Now we'll solve by multiplying both sides by x. They've divided by x, so in order to cancel that, you must multiply by x. Notice here, x is not by itself. We'll need to take another step of dividing by tangent of 54 in order to solve. Once your variable is by itself, we can then type it into the calculator. So we'll type in 87 divided by tangent of 54. You could also use the alpha y equals to set it up as a fraction. Either way, it gives you the same solution. 63.209, and it continues, but notice we are rounding to the nearest tenths place. So the tenths place is 1 after the decimal. Look behind, and if it's 5 or more, it makes it round up. Otherwise, it stays the same. So 63.2 for side SU, that is our answer. Take a look at example number 2. This time we're going to use triangle LMN to find the length of side LM. So for our side LM, let's use a variable. I use x, but you really could use any variable. And now we're going to label our triangle, starting with our theta angle, and then from that angle, label your sides. Of course, opposite the 90-degree angle is the hypotenuse. Opposite your theta angle is your opposite side. And MN is our adjacent side, but I do not recommend labeling that because we do not know anything about it and we don't need to know anything about this side. So only label the sides that you're given and the side that you're asked to solve for to help you determine what ratio you need to use. Because we have opposite and hypotenuse, that is the sine ratio. So we will use sine of theta equals opposite over hypotenuse to solve. So sine of 19 equals, the opposite side is x, and the hypotenuse is 42. So check to make sure you have chosen the correct ratio and that you have set it up correctly before solving. In order to solve, we will multiply both sides by 42. They have divided by 42, so that's why we are multiplying by that value. Once you have the variable by itself, in this case, 42 sine of 19 equals x, we're ready to type it into the calculator. So 42 sine of 19 gives us this 13.67. Because we're rounding to the nearest tenths place, we only need to look one place behind. That is 5 or more, so we'll make this round up. So for our side LM, we have 13.7. Let's take a look at example number 3. Using triangle XYZ, we're going to find the side length of XY. Again, you could use any variable. I chose to use M in this example because we already have the letter X in this problem. So to keep from getting confused, I just chose a different variable. Let's label our triangle, starting with our theta angle. From the theta angle, we have our hypotenuse, which is side XY, and we have our adjacent side, which is side YZ. I do not recommend labeling the opposite side because that will not help us solve this problem. With adjacent and hypotenuse, we can look at our ratios. Adjacent and hypotenuse is cosine for caught another hippie. That is cosine for what we will use to solve this problem. So cosine of theta, we'll plug in our 47 degrees, equals adjacent, which is 26, over the hypotenuse. We'll now solve this equation. Multiply both sides by m. Notice that the variable is not by itself. We'll need to divide by cosine of 47 in order to get the variable by itself. So m is going to equal 26 divided by cosine of 47, and at that moment is when you can type it in the calculator. Make sure, though, your variable is by itself before typing in the calculator. So 26 cosine of 47, if you use the alpha y equals function, it gives it to you as a fraction. So hit math and arrow down to decimal so we can change it to a decimal. If you just divide this, 26 divided by cosine of 47, it should give you straight to the decimal. So it's all in your preference on how you want to type it in. So rounded to the nearest tenth, we have 38.1, because when we look behind that, this 2 is going to make this stay the same. So for side XY, we have 38.1. Let's now look at example number 4. This time we're going to actually find the missing angle measure. We will round our answers to the nearest whole degree. So again, start with labeling your triangle. A is our angle that we want to solve for, so it's our theta angle. And from that angle, label your triangle. We have our hypotenuse and our opposite side. Look at your ratios. Some old hippie caught another hippie, tripping on algebra. Opposite and hypotenuse is the sine ratio. Remember, in order to solve for an angle, you will actually use the inverse sine. So our angle theta, so our angle A, will be inverse sine of 5/10. Because our variable is by itself, our angle is what we are solving for, we're ready to take this straight to the calculator. In order to get the inverse ratios, make sure you hit second and then your button for your ratio, sine, cosine, or tangent. So in this case, second sine, and type in the 5 divided by 10, or you could use alpha y equals. We find that the angle A is 30 degrees. Let's look at example number 5. We're going to find the measure of angle J. So again, label your triangle. J is our theta angle. We have the opposite and the adjacent side. So looking at our trig ratios, sine, cosine, or tangent, the one that uses opposite and adjacent would be tangent. Because we're solving for an angle, we're going to use inverse tangent in order to solve for that angle. So angle J equals inverse tangent. Opposite is 46 over adjacent is 93. And we're ready to type this in the calculator. Once your variable is by itself, type your equation or type your work into the calculator to solve. So inverse tangent of 46 divided by 93 gives us 26.318. We're rounding to the nearest whole degree, so that's the nearest whole number. Look behind that. This 3 will make it stay the same, so 26 degrees. And finally, for example number 6, we're finding the missing angle y. So label that as your theta angle and label your sides. Hypotenuse and adjacent are the values that are given. Use your trig ratios to determine which one you will solve. Adjacent and hypotenuse is cosine, so we'll use inverse cosine in order to solve for this angle. So angle y is inverse cosine. Put adjacent, so 16, over the hypotenuse, which is 20. Type that in your calculator, remembering to use second and then the operation. So second cosine, 16 divided by 20, or alpha y equals to get it as a fraction. Rounding it to the nearest whole degree, we have 36.8. This 8 will make this round up to a 37. So angle y is 37 degrees. So that is all of our notes for solving triangles using trigonometric ratios. It is important that you know your trig ratios and how to use them for finding missing angles. So use this silly sentence to help you remember that.